Hi everyone. In today's video I will be going through the Unit 4 to review Part 1. For this you will want to have your TI-84 plus CE calculator handy along with a copy of the unit circle. Make sure your calculator is in degrees. You can tell very easily up here it'll say degree. If it says radians in that place, you need to go in and change it under the mode. You'll change it right here. Alright, I'm going to try to go through this as quickly as possible. Some of these problems are a bit lengthy, so where I can kind of cut time on some of the shorter ones, I will, starting with this first section here. Does the point lie on the unit circle, yes or no? Your hint is x squared plus y squared equals 1, and that's how you do the problem. You plug in the x value for x and the y value for y, and then see when you add those together if you get 1. So I will demonstrate on A and B, and then I'll just give you the other answers. Still check and make sure that's what you get in your own calculator. If you get an answer different from mine, we definitely need to look into that. So I'm going to do this completely in my calculator. Just takes a little bit of patience, but it does save you a bit of time. So making sure I put parentheses around these fractions. So for A, we have 76 over 45 plus, and then I'll do the negative 31 over 45. And you should already know that when you square a negative, it's positive, so you really don't have to put the negative in there, but if it makes you feel better, go ahead and do it. So that's what you should type in the calculator. Now, if this doesn't say 1, and clearly it doesn't, your answer here is no. It's that simple. All right, B. I'm just going to come up here. I'm going to highlight this, and then obviously I'm just going to change the fractions. So this is 4/5 and negative 3/5. As you can see, that came out to be a 1, so yes is my answer here. So those are the correct answers for A and B. I'll give you the other 6 answers. So for the whole left column, you should get no for all of these. For the right column, you'll have yes, no, no, and yes. Again, make sure you check for yourself that those, in fact, are the answers you come up with. Number 2. If a point 0.22 y is on the unit circle in quadrant 1, what is the value of y? Round to 3 decimal places. Your hint again is x squared plus y squared equals 1. There's a few things going on in this problem. So this time you're given a point and you're told it's on the unit circle, so it has to work in this formula. You're finding the y value that forces this to work. So we need to find what y is. Quadrant 1, I'm going to answer or address that part of it at the very end. So I'm going to replace the x with 0.22, and I'll do that over here. It's where I have the most space. 0.22 squared plus y squared equals 1. 0.22 squared is 0.0484 plus y squared equals 1. Now I just need to solve for y squared. So I'll subtract the 0.0484 on both sides. That's going to give me y squared equals 0.9516. And then, of course, I'll square root both sides to get my y. And in the directions, it says to round to 3 decimal places. If you do this correctly and round to 3 decimal places, you should get 0.975. Now, whenever I take the square root, of course, I'm going to have a plus and a minus case. Because remember, we do have 2 possible answers here. The one that we accept for our problem depends on the quadrant. This is in quadrant 1. You should know that quadrant 1, all your y values are going to be positive. So my final answer here is the positive value, 0.975. Number 3, I'm just going to repeat that same process. If you skim through this, you'll see that it's exactly the same. We're given a point x, y. The x is given still. This time we're looking at a different quadrant, so just remember to think about that at the end. So we have 0.17 squared plus y squared equals 1. 0.17 squared is 0.0289. Subtract that off on both sides. Bring that over here. Y squared equals 0.9711. And then I'll just square root both sides. Y equals plus or minus the square root of that when rounded. That's going to give us 0.985. 3 decimal places. Now all we have to do is figure out, is it the positive one or the negative one? Quadrant 4, that's where y is negative, so we're going to use negative 0.985 for our answer. And that's it. Next section, evaluate the functions, give the exact answer. Hint, these angles are on the unit circle. So, you're going to want your, I apologize to your ears. You're going to want your unit circle handy. So, first things first, just locate where these are at on the unit circle and go from there. Reminder, tangent, since that's where we're starting, is sine over cosine. That's the same thing as the y over the x. We're going to use that in a moment. So, negative pi over 2. We're starting strong here. You may have forgotten that when you see a negative, that means that our starting point, which is at the 0, instead of going counterclockwise, we're going to go clockwise. So if we go negative pi over 2, so instead of ending up here, like usual, where pi over 2 is, we're going to go backwards and end up at what is actually 3 pi over 2. This is negative pi over 2. So we're going to find tangent of 0, negative 1. So remember, tangent is sine over cosine, which is the y value over the x value. So for this problem, that's just negative 1 over 0. You should recognize that as undefined. Number 5, cosine of 7 pi over 6. We just find 7 pi over 6. And remember, cosine is code for the x value. So 7 pi over 6, that's right here. And then the x value is negative rad 3 over 2. Sine of 7 pi over 4, reminder, sine is code for the y value. So 7 pi over 4 is over here, and then the y value, negative rad 2 over 2. Number 7, we have another tangent problem. 4 pi over 3, that's right here. And again, to do tangent, it's the y over the x. So 4 pi over 3, we have negative rad 3 over 2 divided by negative 1/2. And then remember the little trick here, since these both have the same denominator, we can cancel them out. So now we're left with negative rad 3 over negative 1. Negatives, we have two of them, they cancel, become a positive. This is just rad 3. Secant of 7 pi over 4. So reminder, secant is the opposite of cosine. So what we'll do is we'll find the cosine value, and then we'll flip it, and that will give us the secant value. So we need to find cosine of 7 pi over 4. So 7 pi over 4, it's right here. Cosine is the x value, so that's rad 2 over 2. So then we'll flip it, and that will give us 2 over rad 2 for secant. Now reminder, you cannot leave your answer like this, so let's take care of that. Times rad 2 over to rad 2 to get rid of that denominator of a radical. 2 rad 2 over 2, and then one more step to simplify. Notice we have a 2 on top and bottom, so we'll just cancel that out. Rad 2 is our final answer for secant of 7 pi over 4. Lastly, we have cosecant of 7 pi over 6. Remember, cosecant is the opposite of the sine value. So find sine of 7 pi over 6, and then we'll flip it to get cosecant. So 7 pi over 6, that's just past the half circle mark. It's right here. And then we want sine this time. 7 pi over 6, sine is the y value, negative a half. So then we'll flip-flop it to get our cosecant value, and that gives us negative 2. All right. 10 and 11. Graph the given angle in standard position, then list two coterminal angles, one positive and one negative. So we're starting out in the radians first. Theta equals 8 pi over 5. First, we just need to figure out where it is on our coordinate plane. So let's have some reference angles. We know 0 is here. Half a circle is pi. Since we're in fifths, this would be 5 pi over 5. And then if we completed a full circle, that's the same thing as 2 pi, which in this case, that would be 10 pi over 5 to give us 2 pi. So we know 8 pi over 5 is going to be on the bottom half of the circle. And if we think about it, 8 is a little closer to 10 than it is to 5. So it's going to be in our fourth quadrant somewhere. We don't know quite where. So something like that would work. 8 pi over 5. So that would be starting from standard position and going up to that line I just drew. So that's our theta. All right, coterminal angles. That's when you do plus or minus a full circle. So in radians, that's 2 pi. And then in this case, that's going to be 10 pi over 5. So to get the positive angle, we're going to take our theta, 8 pi over 5, and we're going to add 10 pi over 5 to that. And that gives us 18 pi over 5. To get the negative angle, we'll just do the opposite. We'll subtract that 10 pi over 5. And then that will give us negative 2 pi over 5. And that's it. Let's do that again in degrees. Degrees is much easier for us to comprehend. 400 degrees, that's obviously more than a circle. To be specific, that's the same thing as 360 plus 40. So that's one full circle and back into the first quadrant. So we'll end up in here. So that's 400 degrees. And to get the sense of it, that's going in starting position, standard position, going around a full circle and then some. So that's our angle, that's our theta. Positive angle. So we're adding a full circle to our coterminal, or to our current angle, or theta. So adding a full circle in degrees, that's plus or minus 360. So we take 400 plus 360, and that gives us 760. And then again, for our negative angle, we're going to do the opposite. We're going to subtract it. So we have 400 degrees minus 360, and that gives us positive 40. Now here's the problem. This isn't a negative angle. We need a negative angle. So while we did go in the negative direction to get there, we didn't end up with a negative number. So, not negative. We want a negative. So, we do it again. Take that 40, minus 360, and that gives us negative 320. That's better. That's a negative coterminal angle. So, this is the negative angle that we want. So just something to keep in mind. Positive angle, make sure your answer is a positive angle. Negative, make sure it's a negative. It's not keep adding or subtracting until you get what you need out of it. Backside. Convert from radians to degrees. So we need to use our conversion factor. Pi is the same thing. Pi, so that's 1 pi radians, same thing as 180 degrees. So if we're converting from radians to degrees, we want degrees. So we multiply by 180 over pi. because you put what you want on top. We want degrees, so 180 on top. So that's exactly what I'll do. 8 pi over 5 times 180 over pi. We do this because this makes the pi's cancel, which is what we want. And then this actually turns out to be a really nice number. I believe it is 288. Yes, 288 degrees. So if you do 8 times 180 divided by 5 in your calculator, you will get the desired answer of 280 degrees. Let's repeat for 11 pi over 15. And I'll do that up here to give myself room on 15. 11 pi over 15, same thing, multiply by 180 over pi. Pi's cancel. And that one comes out nice as well. It's 132. Those are pretty straightforward. Unfortunately, for the radian problems, we're going to have to do some reducing. So, we're converting from degrees to radians. This time we're starting in degrees and we want radians. So we're multiplied by pi over 180. We want pi on top to get it into radians. So, I'm going to do this very small under this line here. 285 times pi over 180. 285 pi over 180. And then I started by dividing by 5 on both of these to reduce it down. That got me 57 pi over 36. And I assumed that 57 was prime, but it actually is not. Fun fact, if you add the digits of a number together and it gives you a number that's divisible by 3, then this number is divisible by 3. So I thought for a moment, 5 plus 7, that's 12. You can divide 12 by 3, so I can divide 57 by 3. 57 divided by 3 is 19. That is definitely prime, I could tell you that. 36 divided by 3, that is 12. So 19 pi over 12 is our final reduced answer. Let's repeat that for 72. I'll do that up here since I have the space. And since I actually already have this set up, I'll just multiply it on the right side. So that will give me 72 pi over 180. 2 is an obvious one you can divide by here, but let's think a little bigger. I believe I can do this by 4, so let's do that. 72 divided by 4. Is 18. 180 divided by 4 is 45. 3. Let's do 3. 18 divided by 3 is 6 pi. For 45 divided by 3 is 15. And we can do a 3 one more time. 6 divided by 3, that's 2. 15 divided by 3, that's 5. And that is the correct answer, 2 pi over 5. Alright, as you can imagine, these are the problems that are going to take a while. But the more you practice, genuinely, the better you get at these. For the following problems, A, draw the angle in standard position. Find all 6 exact trig functions, so sine, cosine, tangent, cosecant, secant, cotangent. C, find alpha and theta to the nearest minute. So you're going to need your calculator to do the degrees, minutes, seconds. So I'm going to try, I will be able to, I'm just going to have to write kind of small, to fit everything in a designated box for that problem. So it's going to be a little crammed, but it's going to work. And one thing I'm going to do to help with this is I'm going to identify which quadrant I'm in first. That way I draw that quadrant bigger than the others and I can focus on it. Negative 5, 12. So just think about how you would graph that. Negative 5, so we go negative on the x-axis and then up. So this is in quadrant 2. So for that reason, I'm going to draw a huge quadrant 2. So this saves me some space here. So negative 5, I could probably add about here to make it proportional, and then 12 would be about here. Negative 5, 12. There's my triangle. This would be my alpha. And then my theta would go from starting position up to that line. All right, let's work with this triangle. negative 5 for x, and then y is the positive 12. Pythagorean theorem to find this side length. I'll set it up, and then I'm not going to show all of the work. But obviously, if you can't get my number, then you need to ask me some questions. So, Pythagorean theorem, a squared plus b squared equals c squared, or leg squared plus leg squared equals hip squared. So the hypotenuse, h, is the unknown. So we have negative 5 squared plus 12 squared equals, I'm just going to call this h squared because that is the hypotenuse. Reminder, when you have a negative in here, make sure you always put it in parentheses if you rely on your calculator. If you don't put a number in parentheses when you're squaring it into your calculator, then it will use that negative, and it will give you a negative 25 here. We should all be able to look at this and agree that this is not negative 25, it's positive 25, so be extra careful there. If you're worried about it, just drop the negatives because it's not going to make a difference. So if you do this math correctly, you should get 13 for h. Because this gives you 25 plus 144, that's 169. Square root of 169 is positive 13. So that's just light work. What we're really focusing on is the trig functions, the alpha and the theta. So we've got sine of alpha, cosine of alpha, tangent of alpha. And then since there's no radicals in here, and as you'll be able to tell, none of these will reduce to each other, we don't need a lot of space for work here. So let's go ahead and get a little squished. Cosecant, secant, and cotangent. For those of you who need the reminder, sine, cosine, tangent is SOHCAHTOA, SOHCAHTOA. And then, of course, we need to label our sides. I'll make that easier. So we have h is the 13, that's hypotenuse. O is on the vertical. A is on the horizontal. That trick only works if we're in the coordinate plane, by the way. Sine is O over h, 12 over 13. Cosine is A over h, that's negative 5 over 12. Sorry, negative 5 over 13. Tangent is O over A, 12 over negative 5. And then you just flip all of them to get the other three. So we have 13 over 12, 13 over negative 5, 5 over negative 12. Reminder, when it comes to negatives in a fraction, it does not matter where in the fraction that negative is, it's still a negative fraction regardless. Just an FYI. Lastly, before I get into alpha and theta, this is just a very quick check you can do. We're in the second quadrant. If you remember your acronym for which functions are positive and negative where, all students take calculus. All, quadrant 1, all of them are positive. Quadrant 2, all students, S, only signs should be positive here. So you just need to double check and make sure cosine and tangent are both negative, and they are. All right, now I'm going to find alpha and theta. So alpha, you take the inverse of one of these three. You always go for the positive one just because you need to work with a positive number. If you do one of the negative ones, you have to remember to drop the positive. So we're going to do the sine since that's positive already. Inverse sine of 12/13. And then we're going to convert that to degrees, minutes, seconds. I'm going to do this all in the calculator. So first we want inverse sine of 12 over 13. You can do this in a single step or you can do it in 2 steps. I like to do it in a single step, just might as well. So inverse sine of 12 over 13, and then I'm going to go right into degrees, minutes, seconds right after it. So it'll give me my answer I'm needing right out of the gate. So we have 67 degrees, 22 minutes, and 48 point something seconds. So we're going to look at the rounding. We have 30 or more seconds here. So this is going to bump us up to the next minute. We're now at 23 minutes. So this is 67 degrees, 23 minutes. So be careful about that. If you don't round correctly, then it's going to throw off your theta. All right, theta. What we do with theta depends on the quadrant. So having a picture really helps here. If you look at my theta and alpha together, they form a half circle, which is 180 degrees. If I take 180 and I take away the alpha, I'm left with theta. So I have 180 minus alpha here. Don't forget to make sure your answer is in degrees, minutes, seconds. So I've got 180 minus, I'll copy this down. It'll save me a little bit of time. And then I should alter it. So remove the seconds and change this to 23 minutes. And then lastly, I do have to convert it back to degrees, minutes, seconds. The calculator will default to degrees always. So you have to tell it degrees, minutes, seconds. All right, that leaves me with 112 degrees, 37 minutes. And that is one problem. I feel the need to box this, but really the whole thing is the answer. We're asking for all of it. Typically, alpha and theta is the end game, though. All right, I'm going to go out of order here just because 16 and 18 are very similar, 17 and 19 are very similar. So I'm going to do 18 next. -2, -3, that would put me in the third quadrant, so I'm keeping that in mind when I draw this. I'll exaggerate that one compared to the others. All right. -2, -3, something like that. Theta, we start in the starting position and we go up to that line I just drew. So this one's going to look like it's inside the triangle. Triangle. Alpha. Inside the triangle, per usual. Let's label our sides. This side is -2. Running out of room here. Y is -3. And then Pythagorean theorem to find the missing side here. So we have -2 squared plus -3 squared equals, again, we're missing that hypotenuse. This is going to give us 4 and 9. So h is the square root of 13. And that one cannot be simplified, so we're going to leave it as the square root of 13. Just a reminder, this length here is always positive because of that Pythagorean theorem. We're going to keep it as a positive here. All right, the last thing to do is label our HOA before we can start plugging them into our trig functions. So we have h, the hypotenuse, O is on the vertical, A is on the horizontal. Sine, cosine, tangent. I'm going to find those first because I don't know how much room I'll need since I do have a radical now. All right, sine is O over H, -3 over rad 13. And then I obviously have to get rid of that rad 13 on bottom. I will show this one time. The others, I'll just automatically do it. Multiply top and bottom by rad 13 over rad 13. That's going to give me -3 rad 13 over, this just becomes 13 on bottom. Cosine A over H, that's -2 over rad 13. And then that's going to give me -2 rad 13 over 13. Tangent O over A, that's -3 over -2, so that's +3 over 2. All right, they got a little messy. Now, I'll just probably do them all vertically to give me the most space. Opposite of sine is cosecant. And I shouldn't say opposite, I should say reciprocal. I'm going to flip the very first thing I wrote because if I flip the last thing, it's going to make me do more work. Flipping the first, what I wrote, rad 13 over -3. Secant, same thing. Opposite of cosine, reciprocal of cosine, rad 13 over -2. And then cotangent. I am really running out of space here. 2/3. Okay, that leaves me very little space to find alpha and theta, but I'll be able to do it. Let me block this off. Alpha. And actually, before I do this, this is where I like to do my check. We're in the third quadrant. All students take t. Tangent should be positive, the rest should be negative. Positive tangent, the other two are negative as they should be. Let's continue. Inverse tangent of 3/2. Make sure it's in degrees, minutes, seconds. Let me just clear my calculator. Inverse tangent of 3 divided by 2, and then converting to degrees, minutes, seconds. So we have 56 degrees, 18 minutes, and then 35.757 seconds. We have 30 plus seconds, so we can bump this up to 19 minutes. So we have 56 degrees, 19 minutes for alpha. Theta, you want to do this one delicately. Again, the picture really helps. Notice that theta is all of this, which is half a circle, 180, plus the alpha. So I'm going to take that 56 degrees, 19 minutes, plus 180 to get my theta. Going to copy and paste that to make my life a little easier. Delete all these numbers. Can't forget to make that a 19, because that's what I have written down, plus 180. And finally, I'll have to convert the answer to degrees, minutes, seconds. That leaves me 236 degrees, 19 minutes. Just had enough space there. All right, 2 more. These are considered a bit more difficult just because they don't outright tell you where on the circle this information is. You have to kind of work your way with it. So you have to know 2 things. You have to know where you're graphing it, which quadrant, which they actually give us here. 19, it's not outright stated. We have to kind of use context clues to figure it out. So we know we're in the 3rd quadrant. So let me go ahead and draw that plane. And I think I'm going to take advantage of this space up here to do that. Something like that. So 3rd quadrant here. And then we know the secant of theta equals negative 17 over 8. This information looks useless. Don't be fooled. It's extremely helpful. First, secant. We don't like that. Let's change it. Secant is the reciprocal of cosine. So I'm going to flip this. 8 over negative 17. Again, this looks like we're not being told much. We're being told so much. Remember, cosine is A over H. So they're literally telling us A is 8 and H is negative 17. Now, if you really remember, A is the X value. If you don't remember, then you can kind of, the H, that's going to be the part that extends outward. The part that extends, that's going to be the 17. Now, since H has the negative attached to it, how I wrote it, that can't be right. H is always positive. So that means that the 8 has to have the negative. Remember, H, hypotenuse, is always positive here. So let me draw my triangle. And then the A is always on the x-axis, the horizontal. And then if you can't remember that, remember, alpha is always right here. And A is for adjacent, so it's the side adjacent to alpha, which is still the x-axis. So there's the negative 8. Now I can draw my theta. I'm going to kind of cut it close here. Okay. So I was able to still construct my triangle. I'm just missing this side. Let's figure out what it is. Pythagorean theorem. So this time I'm missing the O. Let me go ahead and label these sides while I'm thinking about it. A. O is over here. So we have negative 8 squared plus, I'll call that O squared. I don't like that. What do I want to do? Let's change it to an X. I feel like some people would read that as a 0. x squared equals 17 squared. This gives us 64. Let me just clarify that's an x. Okay, this is 64. I believe that's 289. So we'll subtract 64 from 289 and square root to get our x. Again, I'm not showing all the work mainly just because I don't have the space for it. This one looks like it's going to be nice. I got 15 for my missing side length. Yes. So x is 15. And then be careful here. Notice the side here is going down from the x-axis. So this is a negative 15. If we didn't catch that now, we could definitely catch it later. All right, now we have the information to fill in our trig stuff. Sine of alpha, cosine, tangent. Let's see, nothing would reduce here, so we'll be able to write this out pretty nicely without having to worry about reducing or changing anything. Okay, sine O over H, negative 15 over 17. Cosine A over H, negative 8 over 17. Tangent O over A, negative 15 over negative 8. That's a positive 15 over 8. And then we flip them all. 17 over negative 15, 17 over negative 8, and then 8 over 15. And then quick check on the signs. This is where if you didn't mark that 15 as a negative, this would come up. So third quadrant, only tangent should be positive. So sine and cosine are both negative. Tangent is positive as it should be. All right, let's find alpha and theta. Since this is in the third quadrant, just like number 18 was, the calculations that I used over here, not specific, but like with theta being 180 plus alpha, that's exactly how I'm going to get it over here, since we are still in the same quadrant. Quadrant 3, that is how you find your theta, 180 plus alpha. So alpha, we're going to take the positive function here, that was tangent, inverse tangent of 15 over 8. Convert to degrees, minutes, seconds in the calculator. (15 over 8). And then degrees, minutes, seconds. That gave me 61 degrees, 55 minutes, and then 39 point something seconds. Again, this is over a minute, so we're going to bump this up to 56 minutes. 61 degrees, 56 minutes. And then we do 180 plus that number. I'm going to copy and paste. Make some changes. Make that a 6. Plus 180. And then I'll have to convert to degrees, minutes, seconds. 241 degrees, 56 minutes. All right, one more of these. Make sure you're reading this carefully. A lot of students misread this on our quiz in particular. Cosine of theta equals negative 1/2. Tangent is less than 0, meaning it is negative. And a lot of students interpret this as a positive. Since these are both negative, sine is positive because one of the functions has to be positive at all times, at least one. So that means we are in quadrant 2. So I'm going to draw quadrant 2. And based on my cosine, it's not going to be a large triangle. So cosine is negative 1/2. So same thing. We know that A is 1, negative 1. H is 2. Since there's a negative, H cannot be the negative, so A does get the negative 1. So this is negative 1 on the x-axis, and then we're out 2 on the H. So again, Pythagorean theorem to find our missing side length. So we have negative 1 squared plus, I'm going to use x this time, not O like I did a moment ago, equals 2 squared. This is going to be 4, that's going to be 1, so it's going to give us the square root of 3. All right. This would be our theta. And then we have our alpha. Now, for those of you who are observant and make connections pretty quickly, you can actually tell me theta and alpha very easily based on our numbers. That is all I will say. If you don't notice it, not a huge deal. We'll still go through the motions. But if you do notice it, that is great. All right. Let's do our HOA. 2 is our H. Rad 3 is our O. A is on the horizontal, -1, which is what we were given. So that should work. All right. We have sine of alpha, cosine, tangent, and then I know that rad 3 won't be on the bottom for these 3, so I can kind of squish those. It's these that aren't going to be so pretty. Okay. Sine O over H. Rad 3 over 2. Cosine A over H, -1/2. Tangent O over A. That's going to give me a negative rad 3. And then we flip them all. Cosecant 2 over rad 3, which will give me 2 rad 3 over 3. Secant, that will just be -2. Tangent, that will be -1 over rad 3. So negative rad 3 over 3. Okay, the last piece, alpha and theta. Alpha, oh, this is where we check the signs real quick. I want to use the positive one, which, when I make sure it's the correct one. Yes, second quadrant, sine is positive as it should be. Cosine and tangent are negative as they should be. So we're going to use the sine. Inverse sine of rad 3 over 2. Now again, if you've been paying attention, you can answer this question without the calculator. All right, if you've been paying attention, you should already know that the answer to this question is 60 degrees. Why? Well, we have a special triangle here. We have, ignoring the negative, 1, rad 3, 2. You should recognize that as the 30, 60, 90 triangle. And since alpha is across from rad 3, you should have already known alpha is 60 degrees. And then if we convert this to degrees, minutes, seconds, it should be 0, 0, because it is a solid angle. There's no extra to account for. It is solidly 60 degrees. So in that case, we can just write 60 degrees. There's no point in writing so for theta, since we don't need degrees, minutes, seconds, pretty intuitive what we're going to do here. We have 180 minus 60. We are left with 120 degrees. We are finished with those problems. All right, this we're doing essentially the same thing, but with a lot less work. Find alpha and theta to the nearest minute. And on top of that, we're doing this pretty much exclusively in the calculator. I might draw a little picture here or there just to kind of help with the explanation. Some of you might draw a picture. It really helps me personally. Tangent of theta equals 1.473. So we need to find alpha and theta. We're in the third quadrant. So if you haven't memorized the rules already, or at least can picture it, quadrant 3 is when we do the 180 plus alpha. And I have 2 examples of that for you to refer back to. So whenever I get to theta, that's how I'm going to do it. Alpha, so we just do the inverse tangent of that number. And I'm given this completely, so if they give me a negative, I have to go with it, and I have to remember to drop the negative when I do the calculator. All right. Inverse tangent, 1.473. And then, oh, I almost forgot, it's degrees, minutes, seconds. That gives me, so I look at the seconds first. This is over 30 seconds, so we're going to bump this up to 50 minutes. So we have 55 degrees, 50 minutes. And then 180 plus that. Get rid of all this. And then convert back to degrees, minutes, seconds. And that's going to give me 235 degrees, 50 minutes. Okay, that was one. Sine of theta, we're in quadrant 1. So when we're doing this, again, they tell us the quadrant, so you know how to find the theta. Quadrant 1 is where alpha and theta are equal to each other. I'll actually draw a little reference picture over here. So we already know that this is 180 plus alpha. We've exhausted that already in the third quadrant. And then second quadrant is a half circle when you have it up together. So this is the 180 minus alpha. We did that in problem number 16. In this quadrant, when you draw your triangle, your alpha and theta are both going up to that line. So alpha is equal to theta there. And then for our other triangle here, for our fourth quadrant, I'll draw a picture separately in a post-it note just so my drawing's not crowded. When you're in the fourth quadrant, draw your theta all the way out to here. And then this is alpha. So to get the theta, it's a full circle, 360 minus alpha. So there's all the rules laid out for you. So theta is equal to alpha here. So whenever I get alpha, I have theta. Alpha is inverse sine of 0.8616. Then converting to degrees, minutes, seconds. So seconds, we have 48. We have 30 or more, so this bumps up to 30 minutes. So we have 59 degrees, 30 minutes. And then theta will be the same thing. Okay. Go sine. Quadrant 1, so same thing. Once we find alpha, we'll have theta. This is inverse cosine of 0.2784. And we'll put that in degrees, minutes, seconds. Sorry. Finally, we have seconds that do not round up. We've got less than 30 seconds here, so this stays 50. So we have 73 degrees, 50 minutes. And then theta will be the same thing, since we are still in the first quadrant for this problem. All right, two more. Cosecant. So this one has to be handled a little delicately. So cosecant is the same thing as sine. So we're going to rewrite this as sine of theta. And then just like before, we've always flipped this. So we're going to flip this over itself. This goes 1 over negative 2.749. And then we're in the third quadrant, the second quadrant. That's going to help us find our theta. Sorry for pausing. I just realized that you can't have a negative cosecant. It's literally impossible because the second quadrant is where sine is positive. So this should be positive anyway, which wouldn't have really affected my calculations because when I put in the calculator, I have to turn this into a positive number. Hopefully we correct this on future study guides, so if you have a future study guide and you're watching this, ignore this completely. It should be corrected on your version. Okay, so now to find alpha, we're going to take the inverse sine of this, of that whole fraction. So 2.749, it's all under 1. And then we are getting a little comfy here. So we have inverse sine 1 over 2.749. Okay, and then degrees, minutes, seconds. All right, seconds, we are at over 30 seconds, so this goes to 20 minutes. 21 degrees, 20 minutes. And then theta. We're in the second quadrant. The rule for quadrant 2 is 180 minus alpha. So, 180 minus alpha. Not 108. Minus that. Delete all that. And this bumps up to 20. And then we need to convert back to degrees, minutes, seconds. That puts us at 158 degrees, 40 minutes. All right, number 24. Secant system, we're looking at cosine. So let me go ahead and rewrite that. Cosine of theta equals 1 over that value, negative 13.056. And then they tell us the sine is greater than or equal to 0. So sine here is positive. Since we have a positive sine but a negative cosine, our only option is we're in quadrant 2. That's where sine is positive, the rest are negative. If we had both positive here, then we would have been in quadrant 1. So alpha is inverse cosine. Now this is the first time where we had to be cognizant of the fact that this is a negative. When I put it in here, we have to change it to a positive for it to work. So ignore the negative. 1 over 13.056. Degrees, minutes, seconds. Inverse cosine. 1 over 13.056. And then degrees, minutes, seconds. All right, we have under 30 seconds here, so this stays, at 36 minutes. So 85 degrees, 36 minutes. And then lastly, we need to get our theta. Since we are in quadrant, I didn't even write it down. We're in quadrant 2. I said it, but I didn't write it, so I'm going to forget. Positive sine, negative cosine. We are in quadrant 2. So it's 180 minus that. I'm not going to write this down because I just don't have the space. 180 minus 85 degrees, 36 minutes, which I already had. And then we make sure we're converting it back to degrees, minutes, seconds. Nope. There we go. 94 degrees, 24 minutes. All right, we are done with that. Last section, find the functional value. It's very easy. The only added difficulty is like the bottom 3 where we throw the reciprocal functions at you. Otherwise, we're just typing in what we see here. All right, tangent, negative 197 degrees, so that's under that angle menu still. 50 minutes, also under the angle menu. And they said round to 3 decimal places, so we will do that. Negative 0.3217, so that bumps up to a 2. Number 26. cosine of negative 378 degrees, 20 minutes. (0.949) and sine. And then actually, you can do that shortcut I was just doing a moment ago. You can easily replace the function, and then I'm going to take off that negative. And then this needs to be 179. Sine of 179 degrees, 20 minutes. And then that puts us at 0.012. Yes. All right, 28 through 30 have one small added difficulty. So cosecant is the flipped version of sine. So we need to flip this whole thing. So this becomes 1 over sine of 29 degrees, 30 minutes. I want to explain something for those of you who don't quite see what I'm seeing here. So some of you might ask, well, why are we doing that? Why don't we do sine of 1 over 29 degrees, 30 minutes? One, this personally just comes with a lot of practice. But let me show you one big detail, one big difference that will help you differentiate between the two. 23 versus 28. These are the same type of deal. Notice that there's an equal sign separating my trig function and my value. Here, the whole thing is one value. There's no equal sign except for the one I just added in here. So when you have sine of theta, sine of a variable equal to a value, you flip just the value to get from the reciprocals from one to the other. When you don't have a theta here, you actually have a number, and you're trying to flip it, you flip the entire value. Just a quick reminder here. Let's just add in something real quick. These are the parts of a trig equation. This is the trig function. This is the angle. And then this is the functional value. So this scenario matches 23. So the functional value is on the other side of the equal sign, so we flipped it to get from one version to the other. In 28, we don't have this. We have the left side with a number in it. In that case, when there's a number in here, it's equal to what's on the right side. That's what I'm trying to get right now, is what that number actually is. So you put a number in here, this is the same thing as the functional value. So I flip the whole thing over itself. So in short, when you just have the trig function by itself and the functional value separated by an equal sign, you just flip the functional value. You don't touch the trig function except for changing it. When you have the trig function of a number, you flip the entire thing. Again, if this doesn't make sense right now, this just genuinely comes with time, practice, and seeing enough examples. You know what to do. All right, so let's actually evaluate it. So we need one big fraction, 1 over sine of 29 degrees, 30 minutes. All right. 3 decimal places, that is 2.031. Secant, we flip. That is cosine of that, all under a fraction. And it won't save me much time to do that, so I'm just going to type it from scratch. 1 over cosine of 108 degrees, 20 minutes. All right. Negative 3.179. Last problem. Cotangent, so obviously that's tangent. Tangent of 298 degrees, 30 minutes, all under 1. I will save a bit of time by copying and pasting here. Okay, replace the function, so now we have tangent. 298 degrees and 30 minutes. Negative 0.543. All right, this was the end of the review 1 video. We clocked right in at an hour. I'm sorry the video was so long. We covered a lot of material though. So, if you have any additional questions over this review, feel free to reach out to me either in person or via email. Otherwise, I hope you have an awesome day. Bye!